So today we're going to talk about interpreting velocity graphs and pulling a lot of different information from velocity graphs. We've been doing that with displacement graphs or position graphs, but we're going to do that now. We're transitioning to velocity graphs. One thing that I want you to understand is the acceleration, okay? And acceleration is the change in velocity over the change in time. So what this winds up being is the slope. If you're given a velocity graph and you find the slope, you're actually finding the acceleration, okay? So acceleration, let's write this, acceleration is the slope on a velocity graph. So a lot of times this is given it like this, 5 meters. This is the way we would say this. We would say 5 meters per second. And then per, and then this second. So 5 meters per second per second. Now that's a little bit cumbersome to say that, right? 5 meters per second per second. But what happens is we have another way of writing this. And what this means is that every 1 second, the velocity is going to go up 5 meters per second. So 1 second later, it's 5 meters per second faster. Another second goes by, it adds another 5 meters per second. So what acceleration does, it either adds velocity or removes velocity from an existing velocity. All right. So one thing I want you to understand is, like, this is not the normal way we write the units. So if you look, this is really meters over seconds over seconds. So if we have something like this, 5 meters per second, then what happens is we're going to multiply by seconds over seconds, because that's a version of 1, because seconds over seconds is 1. And when we go to multiply meters per second times seconds, our seconds are going to cancel. And this is the same as 5 meters over, and then this would be second times second, which would be second squared. So you're going to see a lot of times acceleration expressed to us as something like 5 meters per second squared. That's the standard units for acceleration, is meters per second squared. All right, so let's take a look at some combinations of velocity and acceleration and try to interpret what is going on. So what I want to do is I want to start out with a velocity of something like 10 meters per second. And I'm going to have an acceleration that's positive 2 meters per second per second. So every second that goes by, we're going to add 2 to this, 2 meters per second. That's what acceleration does. So at time 0, the acceleration, we haven't had a chance to add any meters per second to the 10 yet. So it's going to start out at 10 meters per second. And then 1 second later, okay, so now 1 second's gone by, and now we've added 2 more meters per second to this, which would now make it 12 meters per second. So at 2 seconds, we'd be at 14 meters per second. At 3 seconds, we'd be at 16 meters per second. At 4 seconds, we'd be at 18 meters per second. At 5 seconds, I almost wrote 6. At 5 seconds, we're at 20 meters per second. At 6 seconds, we're at 22 meters per second. Every second, we're adding 2 more, right? 7 seconds, 24 meters per second. 8 seconds, 26 meters per second. And then at 9 seconds, we're at 28 meters per second. All right, so if you look at this, during this time frame, we're going from 10 to 12 to 14 to 16, 18, 20. We're speeding up. The velocity is increasing, right? Which is telling us that this is speeding up. All of this is telling us that we're speeding up. And if I kept going with more and more time, we would just keep speeding up and get faster and faster and faster and faster. Okay, so what is it that shows us that it's slowing down? Okay, so let's take a look at this. What if we had negative 10 meters per second, but we still had a positive velocity of 2 meters per second per second? Okay, so at time zero, we'd be at negative 10 meters per second. 1 second later, okay, so this is a positive 2 meters per second. And so 1 second later, it's going to add to this, which would actually make it negative 8 meters per second. And then at 2 seconds, we'd be at negative 6 meters per second, because I'm going to add 2 to the negative 8. And at 3 seconds, we'd be at negative 4 meters per second. At 4 seconds, we would be at negative 2 meters per second. At 5 seconds, we'd be at 0 meters per second. Okay, so this is important. The velocity is 0 here. Okay, whenever the velocity is 0, what we can say is that we have stopped. Momentarily, in a moment of time. It's not like coming up to a stop sign and stopping. Like we're just stopped for not even 1 second, like a moment in time. We've stopped. Okay, so 1 second later, we'd be at 6 seconds, and we're adding 2. So adding 2 to 0 would put us, at 2 meters per second. At 7 seconds, we'd be at 4 meters per second. At 8 seconds, we'd be at 6 meters per second. And then at 9 seconds, we'd be now at 8 meters per second. So if you look at the first part of this, right, what was happening in here? We went from negative 10 to negative 8 to negative 6 to negative 4 to negative 2 to 0. And think about what has to happen before you stop. You have to slow down. So right in here, this is showing that we're slowing down. So this is in this interval from 0 to 5, we were slowing down. Now, after 5, okay, we were now going 2, 4, 6, 8. So all of a sudden, after 5, we started speeding up. All right, let's do the next 2. I'm going to slide it up. So now what I want to look at is what if we had a positive velocity, something like 10 meters per second, and a negative acceleration like negative 2 meters per second per second. So at time 0, we'd be at 10 meters per second. 1 second later, okay, now what we're going to be doing, because it's negative, the acceleration is negative, we're going to be removing 2 from the 10. So that would make 8 meters per second. At 2 seconds, we'd be at 6 meters per second. At 3 seconds, we'd be at 4 meters per second. At 4 seconds, we'd be at 2 meters per second. At 5 seconds, we'd be at 0 meters per second. And what did I say earlier? Okay, this is actually, because the velocity is 0, this is meaning that we stopped right here. So at t equals 5, we stopped. Okay, then at 6 seconds, now we're doing negative 2, right? So we're adding negative 2 each time. So at 5, we were at 0 meters per second. So at 6 seconds, we'd be at negative 2 meters per second. At 7 seconds, we'd be at negative 4 meters per second. At 8 seconds, we'd be at negative 6 meters per second. And then at 9 seconds, we'd be at negative 8 meters per second. And if you look right in here, we went from 10 meters per second to 8 to 6 to 4 to 2 to 0. And what happened? Well, we were slowing down here. And I want you to take a look at something. Okay, our velocities were all positive, but we had a negative acceleration. And then here, our velocities were negative, but we had a negative acceleration. So what was happening over here is that we're actually speeding up. because we're going from -2. It just, the negative just means we're going left. So we're going left 2 meters per second, then left 4 meters per second, left 6 meters per second, left 8 meters per second. So we were speeding up there, okay? Now, what happens when you have both a negative velocity, so -10 meters per second, and also a negative acceleration, like -2 meters per second per second? So at 0, we were at -10 meters per second. 1 second later, we were at -12 meters per second. At 2 seconds, we were at -14 meters per second. At 3 seconds, we were at -16 meters per second. At 4 seconds, we were at -18 meters per second. 5 seconds, we were at -20 meters per second. 6 seconds, we're at -22 meters per second. 7 seconds, we're at -24 meters per second. 8 seconds, we're at -26 meters per second. And then at 9 seconds, we're at -28 meters per second. So what is this telling us? Okay, so what's happening? -10, -12, -14, we are speeding up this entire time. Okay, so I'm going to zoom out here, and then we're going to take a look at, okay, what's causing it to speed up and what's causing it to slow down. And there is something that's causing this. So up here, both the velocity and both the acceleration were both positive. And so what was happening, we were speeding up the entire time. Now, down here, the last one we did, it was also speeding up, right? But it had a negative velocity and it also had a negative acceleration, which caused it also to speed up the entire time, okay? Now, in here, we were slowing down. Now, look what happened. We started with a negative velocity, and we had a positive acceleration. And because of that, we were adding 2 each time, right? And so that causes it to slow down, because some of these are going to cancel, 2 of these are going to cancel with 2 of these, right? And so we're going to be slowing down, slowing down, slowing down, slowing down until it reaches 0. And now the velocities start to kick in and they start to become positive. And because now the velocities change to positive and our acceleration is also positive, now we're speeding up. And then kind of the same thing right here, all right? We have a positive velocity but a negative acceleration, so it's causing it to slow down, slow down, slow down. But then all of a sudden we stop, and then after 0, now the velocity is negative, but we also have a negative acceleration. So because the velocity is negative and the acceleration is negative, we're adding negative to an already negative number, and it's just going to get bigger and bigger and bigger, which means it's going to be speeding up. Okay, so how can you tell when something is speeding up and when it's slowing down? Okay, so let's summarize this. I'm going to summarize this down at the bottom. So we know that we are speeding up when, and it has to do with velocity and also acceleration, but it's going to be speeding up when the velocity and acceleration have the same sign. So they're either both positive. Let me slide this over just a little bit so you can read it. So they're either both positive or they're both negative. So if both the velocity and the acceleration are both positive, or the velocity and acceleration are both negative, we know it's speeding up. Okay, so we also know it's slowing down when the velocity and acceleration are opposite signs or have opposite signs. So one is going to be positive and one is going to be negative. So if whenever you see the velocity and the acceleration, like right in here, velocity is positive and the acceleration is negative, you're going to be slowing down. Now, why are we speeding up over here again? It's because all of a sudden we've run out of positive velocity and now we have negative velocity. And now over here, all these velocities are negative and our acceleration is negative. So now all of a sudden they become the same sign and it starts speeding up. All right. So once again, I'm going to say this, okay? So this is the velocity graph, all right? And slope is a big deal on this, okay? So the slope, okay? Slope of velocity time graph gives acceleration. That is the big idea today, okay? That if you find the slope of a velocity graph, that gives you acceleration. And then we can look at the combination of, okay, what's the sign of the velocity and what's the sign of the acceleration, okay? So right here, if you look at this, all right, I can tell because these are all velocities. Now these are all positive velocities and these are all negative velocities. So this is all positive velocity. All the way to 3 seconds we have positive velocity. How do I know that? Because the graph is in the positive region of the velocity, okay? It's up above the x-axis or the time axis. And then down here, all of these velocities are negative down in here. Okay, so I can tell I can tell when the velocity is positive, and I can also tell when it's negative. Okay, so here's the first question. I'm going to zoom out just a little bit. All right, so when is the particle stopped? When is this thing stopped? How do you know when it's stopped? It's stopped when the velocity is 0. Okay, so how can we read that? How can we pull that off the graph? Well, it's where this right here is my velocities. Right here is velocity 0. It happens at t equals 0 and also at t equals 3. So the particle is stopped at t equals 0 and t equals 3 because v equals 0. The velocity is equal to 0 at t equals 0 and t equals 3. Okay, so that's the reason why it stopped. That's why we know it stopped. It's because velocity is 0 there. Okay, so the next question is this. How do you know when the particle is moving in the positive direction? Okay, or in this case, because we're moving on the x-axis, positive direction would be moving to the right. So how do we know when we're moving to the right? Well, you know you're moving to the right when the velocity is positive. So where is the velocity positive? Well, it's positive between 0 and 3. All of this part of the graph, okay, the velocity is positive. Okay, so the particle, we would say the particle is moving in the positive direction when, or for, I should say for, I shouldn't say when, for 0 less than t less than 3. And that's how we write the symbols for in between. Okay, if you wrote the words out in between 0 seconds and t equals 0 and t equals 3, that'd be okay. That'd be another way of saying that. In math symbols, we say it like this: 0 is less than t less than 3. All right, so we know it's moving there. Why? Okay, because the velocity is greater than 0, or you could also say velocity is positive, okay, for 0 less than t less than 3. So it's positive, okay, the velocity, if you write this all out in words, I'm happy with that, okay? The velocity is between 0 and 3, okay, sorry, if the time is between 0 and 3, the velocity is positive there. And that's how I know it's moving in the positive direction, or in this case, right. You could also say up. If this thing was moving on the y-axis, it'd be going up and down, and then we would say the positive direction would be going up. So that's why I don't want to necessarily stick to right and left and up and down, okay, because it just depends on the situation, okay? But right is normally the positive direction, and up is always usually the positive direction also. So the next thing, when is the particle moving in the negative or the left direction? Okay, so that would be when the velocity would be negative. Well, where's the velocity negative? Well, that would be this part of the graph right in here. For all of these times, the velocity is negative. So we would say the particle, or I'm just saying particle, it can be anything, just realize that. It could be a cart, it could be a particle, it could be a bicycle. I mean, okay, it could be anything moving. The particle is moving in the negative direction. Four, and we'd say 3 is less than t, which is less than 6. Now, in this case, I'm going to include 6 because at 6 seconds, the velocity is actually negative, okay? So I'm going to actually also include it here. All right? And why? Okay, because the velocity is less than 0, meaning negative, for 3 less than t less than or equal to 6. Okay, so how do we know when it changes directions? Okay, so we can tell when it changes direction when the velocity changes signs. Okay, so if your velocity is positive and then it's negative, that would mean it changed signs. So where did it change directions? It actually changed directions right here at t equals 3, because just before 3 it was positive, and right after 3 it's negative. So it changed directions at t equals 3. Okay, so the particle changed directions at t equals 3 because the velocity changed from positive to negative at t equals 3. And that's how we know it changed directions, because the velocity changed from positive to negative. If you just say because the velocity changed signs at t equals 3, that'd be fine too. So for the next question, what is the average acceleration between t equals 0 and t equals 2? So that would be this line segment right here. And basically what I'm asking you is what is the slope, okay? So the from here on out, when I write A, I actually mean average acceleration. In this class, they're gonna be the same thing. The average acceleration and the acceleration are gonna be the same thing. So you're gonna start seeing me write just A. So the acceleration would be the change in velocity. Well, okay, so we ended up, okay, at the end, it was at 2 seconds, right? So at the end, it was 10 meters per second. So we're gonna take 10 meters per second, and we're gonna subtract, at the start was 0 meters per second over, and the change in time was we went from 0 to 2, so that'd be 2 seconds minus 0 seconds. So 10 meters per second minus 0 meters per second would be 10 meters per second over, and then 2 seconds minus 0 seconds would be 2 seconds. Again, we could multiply top and bottom by seconds, and that would give us meters on top and seconds squared on the bottom, and 10 divided by 2 would give us 5 meters per second squared. Okay, so this is going to lead to something. Okay, so what this is telling us that the acceleration was the same amount the entire time. Okay, so it was constant, it was uniform. That's another way we say it. So the acceleration was constant, and it's positive, and we also have positive velocity. Okay, so right in here, this is going to answer the question that I'm going to ask on the next page. Is we are speeding up. Okay, so we're speeding up right here. Okay, what is the average acceleration between t equals 2 and t equals 3.5 seconds? So 3.5 seconds would be right here. Okay, so I'm asking you the slope of this segment right here. Okay, so that means the acceleration would be, my final velocity. So at the end of that segment would be right here. My final velocity would be -5 meters per second. And I'm going to subtract the starting, of that segment, the start of the velocity, which is started at 10 meters per second. And the change in time, well, we went from 2 to 3.5, so that'd be 3.5 seconds minus 2 seconds, because we started it at 2 seconds. And so -5 minus 10 would be -15 meters per second over, and 3.5 minus 2 seconds, that would give you 1.5 seconds. And so that gives you an acceleration of, and we would take negative, and we would take 15 and divide by 1.5. And that would give us -10 meters per second squared. Okay, so right in here, if you look, right here, because it's above, the velocity is positive, but I have negative acceleration. So since I have positive velocity along with negative acceleration, I am slowing down in here. Okay, now what's happening between 3.5 and, well, actually in here the velocity is still, the acceleration is negative. So here, let me back up, sorry about this. Here the velocity is positive, but the acceleration is negative. So I'm slowing down until 3 seconds. After 3 seconds, now the velocity is negative, but I still have this negative acceleration. So now right in here, I'm speeding up, okay? And I'm speeding up, and then what happens for the acceleration between 3.5 and 6 seconds, okay? So the acceleration would equal, so at the end of 6 seconds, we are at -5 meters per second. Minus what was the starting velocity, and it was also -5 meters per second. Now, that minus is not a negative, so minus, and we have to subtract the -5 meters per second over, and it's going to be 6 minus 3.5. So 6 seconds minus 3.5 seconds. Okay, so the numerator becomes -5 plus 5, so that'd be 0 meters per second over, and then this would be 2.5 seconds. So 0 divided by 2.5 would be 0 meters per second squared. Okay, so what is this telling me if the acceleration is 0? That means the velocity was not changing. We weren't adding to the velocity. We weren't removing. It was staying the same. And that's what's showing up right here, because if you look, the velocity is the same velocity. It's -5. It's -5 the whole time we're on here. This is a constant, okay, right in here. Those of you guys in Honors Math 3, you guys just got done with piecewise functions. This is a piecewise function, okay, guys? Okay, so now we're talking about when is the particle speeding up, okay? So we got to look at, and it's what I was just talking about, okay, from 0 to 2. So I'm going to kind of mark this out right here. From 0 to 2, on this interval right here, I know my velocity is positive. So v is greater than 0. My acceleration, now think about this. If you took the slope of this, any 2 points on this line, it would always be positive, right? So that would mean, since the slope is positive and the slope is acceleration, then that would mean the acceleration was also greater than 0. And then from 2 to 3, okay, now my velocity is positive still. So v is greater than 0. But now any 2 points on this line, now the velocity is going to be negative because the slope here is negative. And for a velocity time graph, the slope and acceleration are the same thing. Slope is the acceleration. So right in here, the acceleration is negative. So a is less than 0. Okay. You could also say v is positive and a is positive. Here you can say v is positive and a is negative. Right in here from 3 to 3.5, just this little part right in here, okay, right there, my velocity is negative. So you could write that v is negative. But what do you know about your acceleration? Well, your acceleration is also negative. So a is negative. So velocity is negative and acceleration is negative. I'm just writing this a different way than over here if you don't like the way I'm writing this. Okay. And then from here on, my velocity, okay, my velocity is negative, but my acceleration is 0. Okay, so it's not positive or negative, it's just 0. Okay, so how do we know when something's speeding up? It's when the velocity and the acceleration are either both positive or they're both negative. So right here, they're both positive. That's just a way of saying that they're both positive. And right here, they're both negative, right? So the particle is speeding up. Okay, and we'd say, you could say something between 0 and 2 seconds. So for 0 less than t less than 2, okay, so the particle's speeding up there. It's also speeding up right in here between 3 and 3.5. So 3 less than t less than 3.5, because the velocity and acceleration have the same sign. All right. How about the next question? When is it slowing down? Okay, so it's slowing down. And think about this. Right before it stops, it's going to have to slow down. And we said it stopped at 3. So right before that, it has to slow down to stop. Okay, so these things right here, this right here, the velocity is positive, but the acceleration is negative. So that's where it's going to slow down. Okay, so the particle is slowing down. And we'd say 2 is less than t, which is less than 3, because the velocity and acceleration are opposite signs. Okay, and that's what I want you to be able to do today, okay? Is just you're able to tell me, okay, when is the particle speeding up? When is the particle slowing down? When is it moving in the positive direction? When is it moving in the negative direction? When is it stopped? What's the average acceleration for different time intervals? Okay, so all of that is going to be important. Okay, and we're going to do one more thing that I haven't taught you yet, is that we can actually get displacement from the velocity graph. So the velocity graph is like the most important graph because we can get acceleration from it, but we can also get displacement from it. And I'll show you that on the next lesson. Okay, so that's it for today.